Okay, so here's another problem from the discrete distribution section of the actuary textbook. The question gives us, each time a hurricane arrives, a new home has a 0.4 probability of experiencing damage. The occurrences of damage in different hurricanes are independent. Calculate the mode of the number of hurricanes it takes for the home to experience damage from two hurricanes. So immediately I wrote down that the probability we're working with is 0.4. And now we want to identify what type of distribution this is. So we do have that the Bernoulli trials of success and failure are independent, and we model that as success being damage to a home and failure being no damage, which of course feels wrong, but that is how the math is going to work for us. Now, because this is asking us for the number of trials needed to achieve a fixed number of successes in this sequence of independent Bernoulli trials, we know that this is a negative binomial distribution where R, the number of successes, is defined as two hurricanes. So we'll label X as the number of failures, no damage, until two successes. And we can show that this is X is a negative binomial distribution with the parameters of 0.4 and 2. So the next step is to show our probability mass function for X, and super generally, that is R plus X minus 1, choose R minus 1 times the probability to the R times 1 minus the probability to the X. Now, what we want to do is rewrite this so it's something that we can actually solve. So because we're looking for two successes, we can't really solve for X. We're going to need to use a random variable N, and we'll set that equal to R plus X. Now, R is defined as 2, so we can also say that that's 2 plus X. Therefore, my therefore symbol, N minus 2 is equal to X. We can substitute that into our probability mass function. So let's rewrite that. For R, we'll put in a 2. X will have N minus 2 and then minus 1. And for R minus 1, we'll have 2 minus 1. And then we can plug in for our probability. That's 0.4 squared. 1 minus 0.4, we can mental math that to 0.6. And X we have as N minus 2. So here we have a new probability mass function. And again, we're using N because N is going to represent the second success happening on the nth trial or the nth hurricane. We write that down. N equals the second success on nth trial. So let's go ahead and simplify our density function. So the 2's cancel out. So we have N minus 1 over, or choose 2 minus 1 times 0.4 squared times 0.6 to the N minus 2 power. Now, what we should also have done earlier is define that N can only equal integers 2, 3, 4, all the way to infinity, because it must be minimally 2 with when we're looking for two successes. So now we can model at different areas N is equal to 2. So 2 minus 1, choose 2 minus 1 times 0.4 squared times 0.6 to the N minus 2, which is 2 minus 2. So this simplifies down to 0.16, since this is 1 choose 1, which will be 1 times 0.4 squared times 0.6 to the 0 power, which is 1. So 0.4 squared is 0.16. Now we want to see what happens when n is at 3 hurricanes. So 3 minus 1, oh, choose 2 minus 1 times zero point 0.4 squared times zero point 0.6 to the 3 minus 2. That gives us 2 choose 1 times, let's say, 0.16 times zero point 0.6. Now 2 choose 1 will give us 2. So we have 2 times 0.16 times zero point 0.6. And that is a value of 0.192. So we see that the probability increases here. And again, the question is asking us for the mode of the number of hurricanes. And mode, we can define that is where the function is maximized. So because at n equals 3, we see the probability increasing, we'll need to model one more time, minimally. So when n is equal to 4, we have 4 minus 1, choose 2 minus 1 to the 0.4 squared times zero point 0.6 to the 4 minus 2. That gives us 3 choose 1 times 0.16 times 0.6 squared. We can rewrite that as 3 times 0.16 times zero point 0.6 squared as 0.36. And that gives us 0.1728. This is decreasing from our former 0.192. So now we know that the probability is maximized at 3 hurricanes. And because this is the maximum, we know that that is the mode. So the mode number of hurricanes is 3. There is an additional way to solve this. There is a formula for mode, and that is the floor of r minus 1 divided by p. Let me erase that so it looks more clearly like the floor function or symbol plus 1. So when r is 2, 2 minus 1 divided by 0 0.4, again, floored. Just pretend that is a floor symbol. I'll fix it. Plus 1, that gives us the floor of 2.5 plus 1. So 2 plus 1 equals 3. That is a much quicker way to solve this problem, but it's important to note that sometimes a problem can have multiple modes, and this mode will give you the largest mode value. So if we did this problem where r was equal to 3, and we keep everything else constant, you'll see that the floor of this, quickly plug in a calculator, 2 divided by 0.4, that is equal to 5 plus 1. So we get 6. But if we actually did all of the modeling like we did up here, we would see that the values where n is equal to 5 is equal to the probability where n is equal to 6. So we would have a multi-mode in that case. And this shortcut only gives us one of the modes. So that's something to keep in note of. If you are looking for multiple modes, it is going to be easier to model. But if you just want a quick formula, the floor of r minus 1 divided by p plus 1 will suffice.